Hi students, welcome to Max Point of View. Today we are going to understand the concept of current electricity, that is part C, electrical energy and its power. See, don't worry about all these things and get confused. See, we are directly going to jump into the concept. After learning the concept, we are going to solve each and every theory question which is there in the textbook, and we are going to solve each and every numerical which is there in the textbook. Those two videos will also be available in the description box. Okay, listen. So first, see, these are the basic formula we have learnt in part A, and this is what we have learnt in 9th standard also. Using this, we are going to find the formula to find the value of work done. Okay, after that we are going to use the same formula to find the values of power. In this chapter we are going to use many formulas, and I know it is very difficult for you to remember all those formulas. If you get confused in the board exam, then if the formula is wrong, substitution will be obviously wrong, and then the final answer will also be obviously wrong, even though your units are correct. So I am going to teach you how to derive the formula. So when it comes to derivation, don't get confused, because we are going to find the answer through the derivation within one step only. Within one step, how to derive the formula in the board exam instead of by hearting, using the basic formulas. These are the basic formulas. Listen, to find work done, if voltage and charge value is given, then it is very easy. From the basic formula, W is equal to, if you send this Q this side, W is equal to V into Q, correct? W is equal to V into Q. This is the basic formula to find work done. Okay, assume if voltage is given, current is given, time is given. Voltage is given, current is given, and time is given. So then what will be the formula? Don't worry about it. Always write the basic formula. This is the basic formula to find the work done, correct? First, always write, okay, don't worry about this. All the three are given. Now, what is the basic formula? This one, correct? This is the basic formula to find work done. First, you have to write this one. See, all these things instead of by hearting. See, I don't have the capacity to by heart. I cannot even by heart 3 to 4 lines. These methods I am going to use it in the exam. Listen. So as I have used it most of the time, okay, I know all these formulas, so no need to by heart or derive in the main board exam. If you have practiced well, then no need to do all these things also. This will be, instead of by hearting, it will go in your brain automatically if you practice that much. Okay, listen, write always the basic formula. Okay, V is given, write V as it is, and Q. How we can find the value of Q? Instead of Q, we are going to use something. Okay, we can use I plus T, I minus T, I divided by T, I into T, correct? Anything is possible, but go for the basic formula. How can we find the value of Q? Okay, here the work done is we have to find. We cannot use this formula. Here we can use Q, correct? This formula, I and T are given in this question. How to find Q? Q is equal to I into T. So instead of writing Q, you write I into T. So work done will be equal to V I T. I'll repeat one more time. Always write the basic formula. Okay, W is equal to V into Q. V is given in the question. Okay, all these things will be useful in the numerical. V is given in the question. They haven't given the value of Q. So how to find Q? Using the basic formula, Q is equal to I into T. Q is equal to I into T. So this is how we are going to find the value of work done. Now, if voltage is also not given, Q is also not given, how to find it? Always write the basic formula. Always write the basic formula. We don't know the value of V, correct? So how we can find the value of V? Using I and R, using the Ohm's law, correct? Ohm's law. How to find the value of V? Using I in, this will be I into R, correct? This will be I into R. Next, how we can find the value of Q? Again, Q, how we can find the value of Q? I is given, T is given. So Q is equal to I into T. I into T. So if you multiply it, this becomes I square R T. That's it. I square R T, that will be the value of work done. So instead of by hearting, see, these are the final formulas. So to find work done, based on the given data, correct? If those are not given, then how to derive it in the exam, that is what we are going to learn. Okay, this chapter is very easy, few formulas and one or two concepts. Apart from that, there is nothing. Numericals are very much important. Okay, in numericals we are going to use all these things. Instead of by hearting, I am teaching you how to derive it. Then if the value of I is not given, R and T is given. Okay, listen, write to find work done, what is the basic formula? V into Q. V is given, so write it directly. See here, the Q value is not given. How we can find the value of Q? The only way to find the value of Q will be I into T. I into T. So I into T. So here T is given, but I is not given. So how to find it? How to find the value of I? I is equal to, see, Q we are finding, so we cannot use this formula. We can use this formula to find the value of I. Both the values are given, so I is equal to V by R. V by R. I'll write this T as it is. I know sometimes it will be confusing. Go back and again learn it. You will definitely get it. So V into V, V square into T by R. See, these are the many formulas to find the value of work done. So instead of by hearting, if you use it many times, then this will be stuck in your brain. So no need to by heart, no need to derive. But if you find difficulty in the exam, to by heart the formulas, you can go for the derivation part. This is how we used to find different formulas. In the same way, we are going to now find the values of power. Now we formulas for power. Now we found the value of work done. Now we will find the formula for power, okay, using the similar concept, using the basic formulas. See, this is the basic formula to find the value of power. If V and I are given, it is very simple. Power is equal to V into I. You will substitute the values in the SI units. You will definitely get the answer. That's it. Next, if to find the power value using I and R, see, always write the basic formula. Always write the basic formula. What is the basic formula? P is equal to V into I. I is given, I'll write it I as it is. V is not given. How to find the value of V using I and R? V is equal to I into R, right? So instead of V, we will write I into R, multiply it, I into I square and R. That's it. This is the formula to find power. Okay, one more formula. If V and R are given and I value is not given, write again the basic formula. V value is given, right? Write the V value as it is. I is not given. Using V and R, how to find the value of I? I is equal to V by R. So instead of I, I'll write V by R. So V into V, V square by R. That's it. This is the formula to find power. Again, if V, Q, T are given and I and R both are not given, so write the basic formula. Okay, V is given, so I'll write the value of V. Then I is not given. How to find I? Using Q and T. So I is equal to Q by T, then it will be VQ by T. That's it. So if you know the concept, this is how we derive it, the formula in the board exam to find the values. If the different values are given, see, this is the basic formula. If this is not given, we have to go for the alternative formulas only. We cannot leave the numerical as it is, right? So the numericals will be of 1 or 2 marks, correct? If you know, see, if the question is very direct, it is for 1 mark. If the question is not direct like this, okay, these kind of formulas, it will be of 2 marks. So you can get the formula answer within few minutes, correct? So in 2 marks, within 1 minute you can get the answer if you know this technique. That's it. So and after this one, we are going to learn the, see, for power, right? What is the unit of power? Power is equal to, power unit will be SI unit. SI unit of power will be watt. SI unit of power will be watt. And for the numericals, we are going to use just capital W. Now we will learn how power is related to energy. See, energy is equal to power into time. Power into time. Here for energy we have two different units. When the power is in kilowatt and the time is in hours, when the power is in kilowatt, okay, kilowatt, and time is in hours, the unit of energy will be kilowatt hours. Kilowatt hours. If in the same formula, if the power is in watt, okay, and time is in seconds, we will get the answer in terms of joules. We'll get the answer in terms of joules. We know what you mean by kilo. It is nothing but multiplied by 1000. Kilo means multiplied by 1000. That's it. Okay, 10 power 3. Now, what is the unit of energy? The unit of energy will be watt hour or joules. Okay, anyone. If in the numericals it is very much important. If the power is given in terms of watt and time is given in terms of seconds or minutes, you have to get the answer in terms of joules. Okay, if the minutes is given, convert it into seconds, you will get the answer in terms of joules. If the power is given in terms of watt and time is in terms of hours, okay, power, don't worry about this kilo. Okay, whatever the watt is given, divided by 1000, you will convert the value, watt value into kilowatt. So all these things we are going to learn in numericals. Don't worry. If the power is given in terms of watt and time is given in terms of hours, the unit will be for energy will be kilowatt hour. So don't worry about this kilo. I will teach you how to convert this watt into kilowatt in the numericals. Just whatever the watt is given, divided by 1000, the watt will be converted into kilowatt. The energy unit will be kilowatt hour. Now we got to know energy has two different units, correct? Watt hour and joules. So how they are related? Watt hour is equal to 3600 joules. Watt hour is equal to 3600 joules. Then 1 kilowatt hour is equal to 3600. We have multiplied 1000 for this one, unit, right? Again 1000 for this unit also, joules. So instead of writing like this will be written as 3.6 into 10 power 6 joules. So 1 watt hour is equal to 3600 joules. 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. That's it. Now we are going to learn the concept, very easy concept which we have learnt already, but even though we have learnt it, it will be still confusing for the students because of the words they are using. What do you mean by power rating? How power is different from power rating? There is no difference. Power rating is nothing but power only. So power is equal to V into I, and we have learned different formulas, right? So using all those formulas, if you can find for whatever the power we are going to find, that is nothing but power rating. So don't get confused with power and power rating. Both are same only. Use any one of the formulas which we have learned earlier to find the answer of power. That is nothing but the power rating of the appliances, power rating of anything. That's it. Next, resistance in the bulb or appliances. So we know to find resistance, we have two formulas using power. This is about power. Okay, finding the resistance using the power. See, what are the formulas? Power is equal to V square by R, or power is equal to I square R. Correct? I square R. So these are the two values, two formulas using the resistance. Correct? So resistance in the bulb or appliances using the power value, we can find it using these two values. So R is equal to V square by P. We can use this formula, or R is equal to P by I square. Using one of those formulas to find the resistance in the bulb or appliances using the value of power. Next, safe current. Safe current is nothing but the normal current only. Don't worry about it. Whatever the values they have given, voltage and resistance or voltage or power. See, when it comes to safe current, power value they will definitely give. Power value they will definitely give, and they may give this one resistance value or voltage value. In the previous slide we have learned how to find the value of power in different cases. Using one of the formulas you can find the value of current. Whatever the current we are going to find, that will be nothing but the safe current. So when it comes to the words safe current, power rating, resistance in the bulb or appliances, don't get confused. Whatever the normal resistance, how we can find the normal resistance using the given data. data, that will be the resistance in the bulb. How you can find the value of power in a normal way using the given data, that will be the power rating. Whatever the current we get from the formulas we have used, that will be nothing but the safe current. So don't get confused with the watts. Now we learn very easy topic and very important topic. Why? Because household consumption of electrical energy. How much energy is consumed? Based on the energy consumed only we are getting the electricity bill. Okay, every month we'll get electricity bill, right? That is based on this concept only. This is very easy question. Listen. Energy consumption, okay, keep this in mind. Energy consumption is equal to energy spent. Is equal to energy spent. Whatever the energy we are talking about, that will be always electrical energy when it comes to this concept. Okay, see, electrical energy consumption is equal to electrical energy spent. Keep this in mind, because in the numerical sometimes they'll give you electrical energy, find the electrical energy consumed, or find the electrical energy spent will be given. So you have to think, you have to assume both are same only. Okay, we'll use electrical energy consumption, this one for rest of the formulas. That will be equal to power into time. This we have already learnt. Correct? How energy is related to power and time? Electrical energy consumption will be equal to power into time. But the only problem will be power should be in terms of kilowatt and time should be in terms of hours. If, okay, so this will be the answer, whatever the answer we are going to get, that will be in terms of kilowatt hour. So in the same way, electrical energy consumption, the same formula, how to get the answer in terms of joules, power should be in terms of watt and time should be in terms of seconds. So this we have already learnt, how we are going to use this one to find the electricity bill. That is very much important. Listen. So if the power value is given in terms of watt and time is given in terms of hours, the final answer should be in terms of kilowatt hour. How do you convert watt into kilowatt? The power value sometimes, most of the times, will be given in terms of watt only. How do you convert into kilowatt? Whatever the watt value is given, divided by 1000. This we have already learnt. Now we'll talk about the bill. Okay, how the electricity bill will be generated. That based on electrical energy consumption into number of days, okay, into value of 1 unit, kilowatt hour value. So that will be given in terms of rupees, 4 rupees, 4.15 rupees, all those things. So to simplify it, electrical energy bill, okay, how to generate the bill. So how we can find the value of electrical energy consumption? See, most of the time we have to use kilowatt hour method only, because the rupees value will be given in terms of kilowatt hour. For 1 kilowatt hour it is 4 rupees, 1 kilowatt hour it is 5 rupees 25 paise, all those things. So most of the time we'll use this formula to find the electricity bill, not this formula. So this will be kilowatt, okay, power into time, okay, in terms of hours. Okay, for how many hours into how many days, number of days into rupees. Okay, how to use these formulas in the numerical, that is what we are going to learn. Okay, that video will be available in the description box. We are going to solve each and every numerical in the textbook. Don't worry, this is the method I am teaching, that's it. See, watt answer will be given. You should know how to convert into kilowatt. Time should be in terms of hours. They'll tell you, they'll not tell you to calculate the complete electricity bill of a house. They'll give you a different appliances like refrigerator or a washing machine, all those things. A washing machine is used for 4 hours for 28 days, and the value of 1 kilowatt hour is 4 rupees. Then 4 hours into 28 days. If they tell, if it is used for 1 month, then we have to assume the number of days as 30 days, not 31, 30 days, only 30 days. And if the number of days are not mentioned, we can assume it as 1. Okay, assume a washing machine as used for 4 hours every day, okay, for 20 days. 20 days means kilowatt watt value will be given. 4 hours it is used, how many days? 20 days. the value of rupees will be given in the question, substitute it, you will get the answer. But the only method, the problem you are going to face will be converting watt into kilowatt. Just divide it by 1000, the watt will be converted into kilowatt hour. This you should know. If you know this one, see, we are going to solve all the numericals. Don't worry about it. This is the method we need to understand. Now we'll learn our final concept in this electricity part C chapter. Listen. So heating effect of current. So whenever a current passes through a wire or a conductor, for how long the current is flowing, based on that heat energy will be generated. If the duration is long, heat energy, the generated heat energy will also be very large. So to find that answer, H is equal to I square RT. See, the same formula which we use to find the electrical energy consumption, the same formula only, but it is in different format. That's it. See, electrical energy consumption is equal to P into T, correct? P into T. Here we have T, write it as it is. How you can write power in terms of current and resistance? We have learnt it, right? P is equal to I square R, the same formula only, but here we are talking about energy consumption, how much energy is consumed. Here we are talking about how much heat energy is generated. For both the things we are going to use the same formula, so don't worry about it. Okay, now, so what are the factors? By formula only we can answer, right? Current is the one factor, resistance of the conductor, okay, time, how much, for how long the current is flowing. All these are the factors affecting heat. These are the factors affecting heat energy generated. Now, when it comes to heat energy generated, you can write the answer in two forms. Whatever the answer you are going to get for this formula will be in terms of joules. If you want the heat energy answer in terms of calorie, write the same formula, I square R T multiplied by 0.24. The same formula into 0.24, you will get the answer in terms of calorie. Without 0.24, you will get the answer in terms of joules. That's it. So till now we have learned everything about the electricity part C. If you understand all these things, then we have completely understood the concept of electricity part C chapter, that is nothing but electrical energy and power. So after learning this one, we are going to solve each and every theory questions, and we are going to solve each and every numericals. Those two videos will also be available in the description box. Learn everything. Okay, learn everything. See, don't worry about getting 100 on 100. First worry about getting the knowledge. If the knowledge is there, marks will automatically come. You need to understand all these logics, how to find different values of work done, okay, using the different given data, all those formulas. Instead of by hearting, we have learnt how to derive it in the exam. In the same way for power also, if you understand all these concepts, then you have the complete knowledge. You will be able to solve any question. Then automatically marks will come. Thank you.